In this video, our goal is going to be to graph this polynomial. It says f of x equals x to the third minus 5x squared plus 3x plus 9. We'll also do another one at the end. But when it comes to graphing polynomials, we need a few things. First off, we need to know its end behavior. We know the zeros, the multiplicities, and then the y-intercept. And that should give us a good rough sketch as to how it's going to go. One thing we don't talk about in this video is the turning points, how to find those. If you want to stick those into a graphing calculator, you could figure it out that way. Or in calculus, you'll figure out using derivatives how to find the turning points. All right. But for this video, this should be good enough to get a rough sketch. And what we're going to do to start with this one is actually look at the end behavior. All right. This is a degree 3 polynomial because it has the biggest exponent. And if you remember, when if I would just have the graph y equals x cubed like this is going to start down and end up. And what we're looking for is if this is positive, which ours is, it's also going to start down and end up. So that's as simple as we're going to make the end behavior on this one. That's all you need to know. All right. Otherwise, we also have to find the zeros. And this is going to be the hard part of this video because we have to use the rational root theorem. If you remember what that is, we have to use a little synthetic division and find all the possibilities and start dividing until we get something that can divide evenly, meaning there's going to be a factor. All right. So let's look at this one. And if I were to take, remember that you have your p's, which is the factors of your constant term, which in here, this is just going to be 1, 3, and 9. And divided by your q's, which happens to be your factors of your leading coefficient, in this case just 1, well, this list, 1, 3, 9 divided by 1, it's not going to change. It's still going to be 1, 3, and 9. However, you do have to use both plus or minus those ones. So instead of just 3 possibilities, it's actually 6, all the positives and all the negatives. And unfortunately, you just have to kind of work your way through this list until you can figure out something that works. All right, we'll start with 1, and then we'll try -1, then we'll do 3 and -3, and then 9, -9, in that order until we find one that works. So my coefficients here, we have 1, -5, 3, and 9. Use a little synthetic division to help me out. Remember, 1 was a possibility. So if I bring down a 1, 1 times 1 is 1. This is going to be -4 when I add those together, times 1 is, -4. And if I add that, -1 times 1 is -1, and no, that's not going to give me 0. This gives me 8, and because of that, 1 is not a factor. All right, we'll try -1 next. I'll erase this. It's a little bit easier on a whiteboard. On your paper, you'll probably have to rewrite it again. And let's see if -1 works. We have -1, -6, +6. 9, ooh, this one looks like it's going to work. And yeah, it does. So we end up with 1, if you think this is 1x squared minus 6x plus 9. This was our remainder, our constant x and x squared term. And now this thing can actually factor to give us more zeros, because if I were to take, it looks like -3 and -3, both add to be -6 and multiply to be 9. So the factors here are going to have x plus, or what did I say, -3, x minus 3, and x minus 3. But I also need the other factor. Now this is a 0, not a factor. So my other factor is actually x plus 1. Okay, this still would equal 0 if I were going to try to find the zeros. So if I say equals 0 at the end, then I think you can clearly see that this would be +3 if I were to add over the 3 to the other side. This is another +3. So I could say my zeros are +3 and -1 for that one, and -1. All right, and additionally, multiplicities, I have 2 of those, right? I could say this is x minus 3 squared, meaning that at +3, it's going to bounce. What I mean by that is it doesn't go through my x-axis. It's either going to bounce up or bounce down, depending on how our other numbers are in there. All right, so I'm going to get this erased for us, and then we'll put up a graph. All right, so on our graph, we can start putting in a few things. First off, again, it's going to start down and end up. So we'll put those on in a second. All right, secondly, we're going to have zeros at +3 and at -1, like this. All right, multiplicities is going to bounce at +3. So I like to kind of circle mine for that one. And then the last thing I don't have on here is that we have a y-intercept. If I were to plug in 0 for all my x's, that's going to cancel, 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 and I would just be left with 9. So on my y-axis up here, I'd be up at 9. I'm just going to put a dot there. So let's just see if all that would work. If I start down, I'm going to go through this one, come up and hit the 9, turn back down, and I'm going to bounce. I'm not going to go through, but I'm going to bounce and go back up to that arrow. So yeah, I think it would work. Now again, this is just a rough sketch. I think in actuality, it goes a little bit above this 9. So if you were to check out the real graph, so it might go up a little bit here, and then it's going to come back down, bounce, and then finish up. So starts down, finishes up. Our zeros look good. It bounces at +3. And our y-intercept, was at 9. So I think everything checks out there, and that is the graph of this one. Let's try one more before we're done today. All right, our second one, I'm going to warn you, is a little bit tricky, so let's try it. It says 2x to the 4th minus 11x to the 3rd minus 3x squared plus 35x plus 25. All right, now just like before, we can figure out our end behavior. This is a degree 4 polynomial, so it's either both going to be up or both going to be down. And because our 2 here is positive, we know it's both going to be up. So it's going to start up and it's going to end up. So that part's not too bad. The zeros are the hard part on this one because we have to use that rational roots theorem, and it's going to take a couple times. All right. So if we say that we have our p's over q's, this time 25 has factors of 1, 5, and 25. And we need plus or minus that list. Right? Additionally, 2 has factors of just 1 and 2. So a little bit more interesting than the last list. Here, I could say that 1 over 1, 5 over 1, and 25 over 1 is still going to be the list of plus or minus 1, 5, and 25. But additionally, I also have to put those over 2. So 1 over 2 is 1/2. 5 over 2 is 5 halves. And then 25 halves. So it's plus or minus these 1, 2, 3, 4, 5, 6, but plus and minus, so it's really 12 possibilities there as to where those could potentially cross. Again, we'll just start with 1, then we'll try -1, 5, -5, and so on until we find something that works. Okay, so let me get this erased for us, and then I'll put up our coefficients of 2, -11, -3, 35, and 25. We'll start with 1. Bring down the 2 times 1 is 2. 11, -11 plus 2 is -9 times 1 is still -9. It's going to give us a -12, still -12, 23, and 23, and yeah, this will be 48. So not 0. So unfortunately 1 didn't work. Try -1 next. Again, I'll get that erased. This doesn't take up too much paper for you. Bring down a 2 times -1 is -2. -13 times -1 is +13. This gives us 10 times -1 is -10. Ooh, that's looking promising. And yeah, -25. So that one does end up working. However, I'm left with 4 terms. If you can think this is our remainder, constant, x squared, x to the 3rd. Is there any nice way to go from 2 to -13? Not really. And additionally, if I were to go from 10 to 25, this is about, -6.5 times bigger? Well, if I were to take 10 times -6.5, I'd get -65. And I don't think I have that here. I obviously don't have that. So I think I have to just do more of our synthetic division. Again, I can still start with those same ones. 1, -1, 5, -5, and so on. We'll try 1 first. Again, bring down our 2. 2 times 1 is 2. This gives us -11 times 1 is -11, -1, -1, and unfortunately, no, this gives us 24. So 1 doesn't work. Let's try -1 now. So far, I've been getting all the -1s. Maybe this will also be -1. And if it was, that means that there would be a multiplicity as well, because they'd both be there. But it's got to work out first, so let's try it. 2 times -1 is -2. This is -15 times -1 is +15. And this is 25, and yeah, hey, look at that. And we get 25, and is it gonna leave us something nice? This would be 2x squared minus 15x plus 25. Let's see, that'd be 50. Yeah, I could get a 15 out of that. If you need to use a graphical organizer, you can. This is gonna be 50 if I multiply my a times my c. My b term is negative 15. So I think if I have negative 5 and negative 10, multiply to be positive 50 and add to be negative 15. So I split the b term with those two. So instead of negative 15x, I'm going to say negative 5x minus 10x plus 25. All right, let's factor that. By grouping now, I can take out an x, leaving me with 2x minus 5. And can I get 2x minus 5 out over here? Yeah, if I take out a negative 5, I think. Positive 2x and negative 5. Yep. Okay, so I'm going to have a factor of x minus 5, 2x minus 5, and then the ones from up above, remember these are zeros, not factors, so it's actually x plus 1, and there's two of them, so I'm going to say x plus 1 quantity squared. So I'll kind of outline this, or in the dotted line there. So these are the factors of this polynomial, which means I can also find their zeros. If I were to set this equal to 0 and solve, I would have 5. This would be, if I add the 5 and divide by 2, that'd be 5 halves, which is just 2.5. And then I also would have negative 1, and I'd have 2 of those, so negative 1. If you want to put negative 1, you probably could. However, I'll just say that there's a multiplicity at negative 1, and that is going to bounce. All right. Okay, last thing here before I get this erased for us is if I were to plug in zeros for all my x's to find the y-intercept, that would give me 25. So y-intercept here is going to be 25. All right, I'm going to get this erased and draw a graph, and then we're actually going to graph it. Okay, I graphed this, and I put it on the graph kind of in a certain way so that my y-intercept is way up there at 25. I try to make the 5s a little bit bigger, so we have 5, 10, 15, 20, and then 25, I know that my graph, whatever it's doing, is going to cross the y-intercept there. Okay, additionally, it needs to start up and end up. So I'll put some arrows there to remind us. We're going to have zeros at 5. At 5 halves, 5 divided by 2 is just 2.5, so 1, 2.5 here. And then additionally at negative 1, and at negative 1 is going to bounce. So I like to kind of circle that so we know what's happening. Okay, and I already have the y-intercept at 25 on there. So if I were to start up and go down, I'm going to bounce and actually go all the way back up to the 25. And then come down, I'm going to go through this one, back up through that one, and then yes, I would end up. So I think this is correct. Let's try it. Again, just kind of a rough sketch here. Come down and bounce, and then this is going to go way up. And it doesn't necessarily mean it's going to turn right here, but it is going to go through. So it could go way high still, right? But I'm just going to come down. And now I am going to go through this one as well. And then through this one, then I would end up. So again, just kind of a rough sketch of this polynomial, but that's where our zeros are, our end behavior, the multiplicities, and our y-intercept. So hopefully this helped you out, guys, and until next time, keep doing your math homework fast and accurately.